Good day, grade 11s. Today, in this video and the next, we'll be discussing how to tackle a grade 11 final November exam. But specifically, we'll be focusing on question 1. So, in this video, we'll be doing question 1. As you can see, this is the question paper from the year 2018. You can see that question 1 is composed of solving quadratic equations and inequalities. You might need to use surge rules here and there, and then we have to solve a simultaneous equation at 1.2. 1.3, you need to discuss the nature of roots of a function. And then the last question that might need some critical thinking, and you would need to know your work on functions. So, in this video, we'll be discussing question 1 of the grade 11 syllabus, the final exam. This is the final exam. So, as you saw, it is composed of solving of equations. Usually it's quadratic equations and simultaneous equations. Let's get straight to it. So question 1, the first question 1.1.1 says we must solve this equation. So how would you solve this equation? It's straightforward. What numbers, when you multiply this one, it's x is equal to 0, or 2x is equals to 2 plus 0. You can say that 2 plus 1 is equals to 0. What numbers, when you, what this question is asking is, what two numbers when you multiply they give you 0? Which means this number, the first term by itself, it should be 0. Or it's either the second term, which is the one in brackets, is equals to 0. That's when this equation will equal to 0. So here you're not done. You have to continue to say, to solve for x, it's negative 1. So then x is equals to negative half. Then the next question 1.1.2, it's given 5x squared plus 2x minus 6 is equals to 0. So this question, as you can see in the question, it says this answer must be corrected to 2 decimal places. Usually when the question says you must correct to 2 decimal places, you have to know that you must use your quadratic equation. And the quadratic equation, you can find it at the back of the paper. It's given to you in your formula sheet. So what does the formula say? It says that x is equals to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Each of these letters represent the term. I hope you guys know what these terms are, because this is just practice of the final exam. You should know all your work. So the formula says x is equals to negative b, which is negative 2, plus or minus square root b squared, which is 2 squared. We know 2 squared is 4, minus 4 multiplied by a, which is 5, multiplied by c, which is negative 6. all this is divided by 2a, and a we know that is 5. Punch these into the calculator. The calculator will give you what's 4 times 5? It's 20. 20 times 6, it's 120, but it's positive. So, guys, you should use your calculator in this question. You need to be careful when you're pressing your calculator, and you press your calculator clearly. Double check that you press it the numbers right. You will find that x is equals to 0.91 for the positive, and you'll find that x is equals to negative 1,31 for the negative. Right, we move on to the next question, which is an inequality. An inequality, you solve it in a different manner. So this inequality is in a form of a quadratic equation. As you can see, a quadratic equation, you want all the terms on one side, and the one side must be 0. So you're going to have to move this 3x to the left hand side, and when you move it to the left hand side, it changes its sign to become negative 3x is bigger or equals to 0. Right? You want to rearrange this in such a way that it's in the standard form of the quadratic. Right? So this can be factorized. And when you factorize here, let me give you a little trick that maybe your teachers didn't teach you. So as you can see, this quadratic function, it doesn't have a common factor, so we can't take out common factor. What you do in this situation is you divide the first term by its coefficient, which is 2, and then you multiply the third term by what you divided the first term was, which is 2. And when you divide the first term by 2, you get x squared. This middle term, you don't touch the middle term. And then you move to the third term, you multiply it by 2, you get 4. It's bigger or equals to 0. Now it's something we are able to solve. Factors of 4 when you subtract give you 3. What are those? It's 4 and 1, because 4 minus 1 is 3. Factorization is something that you did in grade 10, something that you need to be comfortable with all the time, because it pops up everywhere, even when you're doing functions. So the common factors is that you put x this side and x that side. This is factorization. Since it's negative here and negative there, it means the bigger one must get a negative and the other one gets a positive. So you see that your critical values are 4 and negative 1. So you would have to draw these on the number line. Because we are dealing with an inequality. This is where negative 1 is, and this is where 4 is. This is the number line. Numbers from here, excuse me, I'm sure you can't see what's happening here, but this is the number line, and you plot your critical values onto the number line. So from here to that direction, we know we're going to negative infinity. And from 4 to that direction, we know that we're going to positive infinity. So, what is our inequality telling us? We want to know how this function behaves in the number line. So, if you take a number bigger than 4, you can pick any number that's bigger than 4, like 5, 6, 7, 8, 9, 10, any number that's bigger than 4. So I'm going to choose an easy number 5, and substitute it into this function. So I'm gonna substitute 5 in this equation. So you'll find that it's 5 minus 4. 5 minus 4 and 5 plus 3. 5 plus 1, not 3, 5 plus 1. So this is equals to what? 5 minus 4 is 1, and 6 plus 1. These numbers are both positive. So it's a positive number multiplied by a positive number. It's going to give you a positive number because these two numbers are both positive. You put a positive here. Since it's positive here, it's negative here, positive here, right? So we look at our inequality. And we check, what is the question? The question wants where the function is bigger than 0, bigger or equal to 0, where it's positive. So it's exactly here. It's from 4 up to infinity, and from negative 1 going to negative infinity. It's within that area. So we want x to be less or equal to negative 1, or we want x to be bigger or equal to positive 4, and that's it. That is how you tackle a inequality. Moving on to the next question. The next question is about using surds. So the square root of 2x plus 5 2x plus 5 is equals to negative 2. So we are given, it would be nice, we are given this monster here. So you would need to solve this. As you can see that this looks like a very complicated question, and that's when you would need to introduce a k using the k method. The k method makes the question to become very simple. So how you use the k method, you say let k equal to the monster that you see there, 2x plus 5, so that the question becomes simple as 3, like you substitute k for that and you get this simple question. Now what you do is you multiply each term by k, because when you're solving for x, you don't want fractions. We do not love fractions when we solving. So this will become k squared minus 3k is equals to negative 2k. You bring the 2 to the left hand side, it becomes positive. You get you get your quadratic equation again. You need to solve this quadratic equation using factorization from grade 12, from grade 10, which I assume you know very well. So the factors of 2, we want the factors of 2. We want the factors of 2. Sorry guys. When you multiply in k, when you multiply each term here by k, this first term is going to be k squared, but when you multiply this term by k, the k's are going to cancel out with this k. It's going to cancel out, it's going to be just 3k, and this final term is going to be k. Guys, you see, you need to be careful in maths. You need to check your work every time. You can do a careless mistake anytime in the exam. So do not rush. This reads 3 squared minus 3 plus 2k. So this becomes, you want the factors. You see now, since I made that mistake, the orientation of this question is not clear. What you need to do is order it in standard form. So standard form is like this. The 2k must be in this side and the 3 must be this side. I'm sorry for that, guys, but you want the factors of 3 that when you subtract, they give you 2. So these are 3 and 1, because 3 minus 1 is 2. The bigger term is supposed to get positive, and the small term gets, it's a k here and k there. So we can see clearly that k is equals to negative 3, or k is equals to 1. But we said that k is equals to the square root. So k being the square root, we need to substitute it back, which is equals to negative 3, or in this side, it's equals to 1. But in this case, this can't be a solution. There's no solution to this equation, because this square root can never be negative. It can never be less than 0, because what you input inside a square root is positive numbers, and by itself is a positive number. So this is not a solution. This case is the solution. So in this case, you need to, once you remove the square root, so you're gonna have to square both sides. So it's going to be 2x plus 5. When you're squaring, you have to square both sides. You get this. You need to solve x. So x on one side and numerics on the other side. It moves that. It becomes negative 5. When it becomes negative 5, it's 1 minus 5. So that you get basic maths. This is basic grade 8 maths when you did division, such that this is equals to. Are we happy? You guys can rewind the video if you think something was unclear. You can move back and take your time. Check my work where you think I made a mistake, and you will see what's going on. Now we're moving on to simultaneous equations. So where you would need to solve for x and y. You need to solve for x and y in the same time. So you are given two equations. You are given two equations, x plus y is equals to 2. You call this equation 1. When you get equation 1, try to solve one of the variables. So I'm going to choose to solve for y. Y is equals to 2, and then this x jumps to negative x. And then the other equation, this is equation 1. This is the same equation 1. I just rearranged it. It's the same equation. And then you're giving another equation, x squared plus 3xy plus 8 is equals to 0. Let's call this equation 2. So you need to solve this simultaneous equation problem. How would you approach it? You would have to solve it using substitution, because that's why I solved for y, because I want to substitute y into equation 2. What you do is you substitute 1 into 2. So you substitute this y into this equation. What will you get? You get that you put, instead of y, you put 2 minus x plus 8, it's equals to 0. So what is this? This is x squared plus, multiply in, because there's a bracket, 6x minus 3x squared plus 8 is 0. So what do you get? You get this x, 1x minus 3x is minus 2. It's giving you minus 2x squared plus 6x plus 8 is equals to 0. Here in this equation there is a common factor, which is 2, so you divide all of them by the common factor, which is negative 2. X squared minus 3x minus 2 minus 4 is equals to 0. What I did here, I just divided everything by 2, and now it's a simple quadratic equation where you can be happy to solve. Equations of 4, when you subtract, they give you 3. It's 4 and 1. It says here the middle term tells you that the bigger term gets a negative, and this one must be a positive. Put an x here, put an x there. Then now things are clear. You can see that x is equals to 4, or x is equals to negative 1. So if this is the case, then what is y? Y, we know from the top, we know that y is equals to 2 minus x. So y is equals to 2 minus x, but we know that x is equals to 4. So y in this case, it's equals to negative 2. But on the other hand, we have that x is equal to negative 1. So you need to substitute for negative 1. It's negative 1. So negative and negative gives you positive. A negative and a negative give you positive. So this is 2 plus 1. It should give you 3. So yeah, these are your final answers. You can write them in coordinate form, and here you have it. That's how you solve your quadratic equations. And then now moving on to the next question, which is a question about the nature of roots. The nature of roots. It says that we must find. They're telling us that the nature of excuse me. It says here that it is found that a function's roots are. They give you the roots. They say these are the roots of a function. These are the roots of the function. These are the roots of the function. So this question, guys, it's a really, really important question. It comes out every time and it catches people every time. And it's talking about the nature of roots. Can you see, does this formula look familiar, guys? Is this formula familiar? This is the formula of the quadratic equation. Solving a quadratic equation, use this formula. So this formula is for solving quadratic equation, and also it tells us something about the roots of the equation. So this something is identified within the square root. So what is within the square root tells us something about the roots. This number under the square root tells us something about the nature of roots. Let me write this number down. Usually this number is known as the discriminant, and it's the number underneath the square root, which is 16 minus 4m into negative m plus 5. So this number, this discriminant value, tells us the nature of roots. Now, let me tell you something about nature of roots. So the nature of roots of a function are described by the number under the square root, which is called the discriminant value. And this discriminant value is used for quadratic equations, which have this discriminant value is b squared minus 4ac. So if this discriminant value, if it's less than 0, then the function doesn't have no real roots. The roots are not real. They are not real because this value is less than 0. The roots of a quadratic function can be real only if this number is bigger than 0. If the number is bigger or equal to 0. If this discriminant value is bigger or equal to 0, then the roots of this function will be real. The roots will be real roots. They will be roots from the element of real numbers. And then if this number is equal to 0, it means that the roots of the function are equal. They are equal. They are the same. So these are the only 3 cases of the nature of roots. when this discriminant value is less than 0, when it's bigger than 0, or when it's equal to 0. Back to our exam question. In our exam question, they asked us to find the value, they want us to find the value of m for which the roots are not real. So you saw that we know that the roots are not real if this number is less than 0. So if the discriminant value is less than 0, so we're going to say this discriminant value is less than 0. 16 negative 4m, you multiplied in first with negative m. Negative times negative is positive 4. M and m give you m squared. M and m give you m squared. 4 and 5, 4 multiplied by 5 is 20, but a positive times a negative is a negative 20. M is less than 0. So as we can see that this is a quadratic question now. This is a quadratic equation where, and actually it's not a quadratic equation. In actual fact, this is a quadratic inequality. So this quadratic function is must be less than 0. So you need to divide this by 4. Each term is divided by 4 because there is a common factor. When we factorize this, we find the common factor. We see that it's 4, and you find m squared. Divide by 4, it's m squared. Divide 20 by 4, it's 5m. And you divide 16 by 4, it's 4. Simple as that. So since this you can it's a trinomial, you can factorize it. We want factors of 4 that when you add give you 5. So it's 4 and 1 because 4 plus 1 is 5. The middle term tells you that the bigger number gets a negative. M this side, M that side. They are both negative because this number is plus. So we see that our critical values are 4 and 1. You draw this on the number line. You draw 1 just like we did in the previous question, question 1.13. So you put a 1 here and you place a 4 there, as if this is a number line. This is a number line. It's going to negative infinity this side, it's going to positive infinity the other side, right? So you plug in numbers in this equation, m minus 4 multiplied by m minus 5. You plug in a number who's bigger than 4. You can take 5, you can take 6, you can take 7, you can take 10. Let's take 10. If you plug in 10 in this formula, it will be 10 minus 4 is what? It's a positive number, right? 10 minus 4 is 6, which is positive. And then 10 minus 1 is 9, which is what? Another positive number. You can't use only 10. You can also use any number. You can use 9, you can use 20, you can use 100. Any number that's bigger than 4. We see that these two numbers are going to be positive and you know a positive and a multiplied by a positive is a positive number, so you put a plus here, you put a minus here, then you put a plus here. It's always opposite, 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 right? So in our inequality, they wanted us to find where it's less than 0. So where it's negative, we will focus on this area where it's negative, right? So in this area, we see from the inequality that we're not including the bounds. They are not included because it's not equal to sign. So you could just say that x should be an element for numbers between 1 and 4. That's it. Or another notation you can use is when you put bounds like this for x. This is the interval for which the roots of this equation will not be real. So if you take a number from this interval and plug it in for m, we're plugging it in for m. If you plug it in for m, it will be not real. It won't be real. Now that's it for question 1. We move on to question 2. Question 2 is more about exponents, and it's more about exponents, surds, using surd laws and all of that, all of those nice stuff. So we're moving on. So question 2, which is about surd laws and simplifying without a calculator. So 2.1, we need to simplify this expression. We need to simplify this expression as far as possible. So as you can see, that this is an exponent question. If you don't know all your exponent laws, you're going to be chewing bricks in this question. So you need to know all your laws of exponents, your power laws, when to add, when to subtract. So you need to consult your textbook for that. So how do you tackle this question now? Step 1 is you break this down. Break this down into smaller parts. So it's going to be 2 to the power of x multiplied by 2 to the minus 3. You subtract 3 multiplied by 2 to the x. You break this down to another 2 to the power of 1, since this is 1. All of this is divided by 2 to the power of x multiplied by 2 to the minus 2. So you can see I first break it down from these exponents, and now you can identify a common factor in the numerator. The numerator has a common factor, which is 2x. You take out the common factor. And then you leave the denominator in its simple form. These cancel out, and then you're left with 2 to the minus 3. Minus 3 times 2, we know it's 6. This is divided by 2 to the minus 2. In maths, we don't like working with negative exponents, so what do? We change this to become 1 over 2 cubed minus 6 divided by 1 over 2 squared, right? Remember, in this question, you're not allowed to use your calculator. So this is 1 over 8 minus 6 over 1. All this is divided by 1 over 4. So you can continue using your past knowledge from grade 3 all over the years, all the maths you've learned all over the years, you need it now. So these are fractions, and they need, when you need to subtract fractions, what do you need to have? They must have the common denominators that's the same. So this must be multiplied by 8, and then obviously the numerator you have to multiply by 8 as well. And then it's divided by a quarter. What is this? 6 times 8 is, you can use a calculator or you can count off by heart. So it's 6, 12, 18, 24, 48. So 1 minus 48 divided by a quarter. What is that? It is negative. Get negative 47 over 8 divided by a quarter. So since you're dividing a fraction by a fraction, you can use the reciprocal rule. You can use the reciprocal rule that says this number can be changed to 4. So what would you get? Negative 47. This number and this number, they can divide by 2. And that is your answer, negative 47 over 2, without the use of a calculator. Now on to the next question. Still on question 2.2.1, where you need to solve for x. So you need to solve for x. So you need to solve for x here. What's the first thing that you want to do? You want x on one side and numbers on the other side. So this is negative 16x to the power of negative 3 over 2. When 2 moves to the other side, it becomes negative 2. And then what you do now is you divide both sides by negative 16. What do you get? Because you want to cancel this out, you get that x is equals to negative 1 over 8. But we know that 8 can be written as 2 cubed. And then you move, because we don't like numerators, we don't like fractions very much in maths, we're going to move this to the top. It becomes negative 2, and when it moves to the top, it changes the sign, right? Now we want to solve for x, so what do? We want to get rid of this power. So how do you get rid of this power? You multiply by negative of its reciprocal, which is 2 over 3 in this case. You have to multiply this side also by negative 2 over 3 so that everything could cancel out and it's all out. You can get that x is equals to negative 2, and this side, this 3 and this 3 cancel out. Negative and negative give you positive, and you left it positive 2, so we find that x is equal to negative 4. Guys, you need to know all your laws of exponents for this question. The next question is also in solving of equations. So you need to solve an equation for 4x plus 8 is equals to 9 times 2 to the power of x. So what do you do here? First things first, you can see that you can change this 4 into 2. You can change this to 2 to the power of 2x, right? Plus 8, which is equal to 9 times 2 to the x. This can be seen as 2 to the x squared plus 8, which is equal to 9 times 2 to the x. In this question, we can use the K method again by saying that let 'k' equal to 2 to the x, because we want to use the K method. So we say k is equal to that. So k squared plus 8 is equals to 9 times k. Because every time when we see 2x, we substitute k. So k squared plus 8, that 9k must be sent this side, because now this is a new quadratic question. It's a quadratic equation that needs to be solved like a quadratic equation. So we want factors of 8 that when you add, they give you 9. It's 8 plus 1 is 9. This tells you that both the signs must be the same, which you take from the middle term. So clearly here k is equals to 8, or k is equal to 1. But we know that k is equal to 2 to the power of x is equal to 8. 2 to the power of x is equals to 1. You change this 8 to be a power of 2 because in equations, when bases are the same, you can drop the exponent. That's why we want this to be of a base of 2. Even on this side, we want this to be in a base of 2. 2 to the power of 0, we know it's 1. So you just drop the bases and you get 0. Guys, you need to know all your work when it comes to exponents and surds. And now, on to the next question. This question is still on question 2, so we're still going to be playing with exponent laws and some surds when necessary. So This is a question. Given the question like this, and this root can be written as a power. This question is written like this, and we can change the question such that it is written as a power. So 9 to the power of 1 over x, since this is the root. And then we want to write this number in its simplest form. So we want to write it as a power. So this big number is 3 to the power of 5. And also we know that 9 is equal to 3 squared. So we have this. But these are brackets, and we know from the rules of exponents that if we have brackets, it means we must multiply.